Greetings everyone. Allow us a few minutes for presenting you the new innovative advances made by Compass on top of the simulation software Tdyn. Give us first a moment to present Compass. We are a consulting services company with more than 20 years bringing value to customers with innovative solutions. Compass has success trajectory conducting large-scale projects with international companies concerning engineering design and advanced technical consultancy services in naval architecture and many other engineering fields. Also, Compass is devoted to the development and commercialization of software for numerical simulations. Steen uses GiD's pre-post processing and meshing advanced capabilities and tools. Compass is proud of its continuous and close collaboration with technological research centers as SIMNI, home of the GiD team. Steen is a unique integrated package solution for structural, flow, heat transfer, coupled fluid structure, multiphysics, and seakeeping problems. Its user-friendly, fully integrated graphic user interface, GUI, is based in GiD and CustomLib and allows for geometry and data definition, mesh generation, and post-processing of results. Steen integrates 3 analysis packages, offering 12 simulation modules altogether, and today you will discover the new enhanced automatic graphic user interfaces for automated simulation setup, Tdyn WindTunel and E-SeaFEM. Tdyn WindTunel is based on Tdyn CFD plus HT, which is a robust numerical simulation code for multiphysics problems with more than 20 years on the market and uses the Stabilized Finite Element Method, FIC. By means of this stabilized numerical scheme, Steen is able to solve, for example, heat transfer problems in both fluids and solids, real 3D turbulent flows, species advection, and free surface problems. Tdyn WindTunel is a new advanced interface for virtual wind tunnel, outstanding for its easy operation, allowing to prepare simulations in less than a minute. It facilitates CFD simulation for novice users, minimizing errors and efforts, and meets the needs of experts by including the power of a complete CFD. Its main applications are the analysis of flows around any type of structure or shape. Tdyn WindTunel incorporates optimized tools for importing geometry in different CAD formats like IGS, STEP, Rhino, or GiD models. It also has specific preprocessed tools for adjusting planes, dealing with symmetries, rotations, and scaling of models. The interface incorporates multiple graphic tips and detailed instructions and advice to optimize this import process and help the user to correctly set up the imported geometry. The first step is to prepare the 3D CAD model to be analyzed so that all the surfaces that make it up are closed, without duplications or gaps, ensuring that they form a connected domain. This can be easily verified by trying to generate the volume contained by said surfaces of the model. Once this is done, the user can proceed to import the model geometry into the Tdyn WindTunel interface. It is important to highlight that this pre-process workflow, which includes the repair, preparation, and import of the model to be studied, as well as the next step of domain generation and assignment of boundary conditions, is generally the one that requires more hours of work and intervention of technical personnel. Therefore, within simulation and prototyping activities, it is vital to equip yourself with the appropriate tools to speed up and optimize this pre-process. Once the model geometry has been successfully imported, the next step is to configure the simulation. The user only has to enter a very limited number of parameters from which Tdyn WindTunel creates the appropriate domain, assigns boundary conditions and mesh sizes, and establishes the appropriate values for the analysis parameters related to turbulence, laws of wall, and numerical integration schemes. The parameters to be introduced by the user are wind speed, results precision within a given range, symmetries, and floor position if it is considered. Based on such parameters, the domain around the object is generated. The dimensions of both the domain and the subdomains created to refine the mesh around the object are the optimal ones corresponding to the speed and size of the object, and are determined by means of internal algorithms. The time step and total duration of the simulation are also internally determined, upon convergence criteria and assuming that the time it takes for the flow to travel through the entire domain is sufficient to largely overcome any transient effect, and therefore obtain a pseudo-stationary and stable solution of the flow. The last step before launching the simulation is to generate the mesh. Since the mesh sizes have already been selected internally and automatically assigned in the previous step, the mesh generation process is immediate and performed internally by GiD. After generating the mesh, it is possible to both view it and review the different parameters that give a reference to its quality. Finally, the user can launch the calculation, being able to visualize both the evolution of the process and its convergence, as well as the evolution of the pressure forces integrated on the body. This evolution of pressures will give a very good idea of the stabilization of the calculation. In addition to all the visualization and post-processing options for results already present in Tdyn CFD plus HT, the Tdyn WindTunel interface presents specific tools for automatic generation of cutting planes and streamlines. A quick viewer has also been incorporated for all the cuts and streamlines generated. Tdyn WindTunel is a robust numerical simulation code for problems of seakeeping, towing, maneuvering, extinction tests, and obtaining RAOs with more than 15 years on the market, which uses the finite element method, FEM, for resolution of the wave radiation diffraction problem with multi-bodies in the time domain. E-SeaFEM is the new advanced graphical user interface that enables quick and easy creation of towing tank test analysis models for time domain seakeeping FEM simulations using the powerful Steen CFEM solver. E-SeaFEM asks the user only for the data necessary to configure and generate the domain and mesh for the simulation of behavior at sea in a few clicks, as well as to run the analysis and visualize the results. The user can always open the full Tdyn WindCFEM interface to add even more complexity. In the case of E-SeaFEM, only the capabilities of the basic module, first-order problem resolution, are used to generate the initial models automatically, although, as already mentioned, it is possible to use the full functionality of Tdyn CFEM a posteriori. As for the wind tunnel, the first step is to prepare the 3D CAD model to be analyzed, so that all the surfaces that make it up are closed, without duplications or gaps, ensuring that they form a connected domain. This can be easily verified by trying to generate the volume contained by said surfaces of the model. Once this is done, the user can proceed to import the model geometry into the E-SeaFEM interface, which offers the same CAD import options as Tdyn WindTunel. The interface also provides specific detailed instructions and tips for optimizing the import process. Again, it is important to highlight that the pre-process flow, repair, preparation and import, domain generation and assignment of boundary conditions is one of the bottlenecks of FEM analysis and simulation, so having the appropriate tools to streamline and optimize these activities is crucial. E-SeaFEM, like Tdyn WindTunel, directly attacks this problem and provides an optimized solution. After the successful import of the CAD model, it is necessary to configure the simulation. In this case, the user must enter certain parameters corresponding to the sea conditions, location, and properties of the vessel itself. After this, E-SeaFEM automatically generates the specific domain, assigns boundary conditions and mesh sizes, and establishes the appropriate values for the parameters of the numerical integration schemes. The data to be entered and modified by the user are data such as the depth in the zone, the distance at which the effects of the ship on the free surface are no longer considered relevant, the simulation duration, data related to the state of the sea or data about the ship, as the position of the center of gravity of the ship, its radius of gyration, the displacement, and the degrees of freedom that we want to consider for the simulation. Based on the data entered, the domain around the vessel is automatically generated, adjusting to the requirements of the sea conditions and the indicated depth. The dimensions of both the domain and the subdomain created to refine the mesh around the object and its zone of influence are the optimal ones corresponding to the size of the ship, the numerical beach parameter introduced, and the maximum length of the waves. An internal algorithm is used to define the domain and subdomain. In this case, the determination of the time step is done through the so-called free surface stability factor, which is a convergence criterion similar to that of Courant, which relates the time step to the volume mesh size immediately below the free surface. After this step, in addition to determining all the mentioned parameters, E-SeaFEM automatically applies all the necessary boundary conditions, leaving the model completely defined and ready for meshing and for performing the calculation. Likewise, once the model has been generated, it is possible to view and modify the generated data, accessing the complete Tdyn CFEM interface from the E-SeaFEM interface. In the case of E-SeaFEM, the user is offered predefined mesh sizes by default, based on the geometry of the model and internal algorithms, which in any case can be modified by the user. As an interesting and very useful tool, E-SeaFEM also incorporates the possibility of generating and previewing partial meshes of the hull, free surface, and interior volume. Once the mesh is generated, everything is ready FOT launching the calculation. E-SeaFEM offers the same visualization of results relevant to seakeeping analysis as Tdyn CFEM, free surface elevation, total hull pressure, and vessel dynamic response plots over time for motions, speeds, and accelerations. Tdyn WindTunel and E-SeaFEM represent a significant advance in the field of naval design and calculation. These tools offer innovative and efficient solutions that adapt to the needs of the sector, promoting competitiveness and the development of new technologies, and promoting the integration of advanced calculation tools in the workflow of the Shipyard 4.0 digitalization paradigm. As a summary, it can be said that these tools presented offer a series of benefits for naval engineering, such as workflow optimization, improved accuracy and reliability of results, greater flexibility and innovation in design and analysis, and integration with other software. The use of these tools can help engineers be more competitive in the global market. The adoption of these technologies is expected to continue growing in the future, driving innovation in the naval and other industries. This presentation has shown an overview of the functionalities and benefits of Tdyn WindTunel and E-SeaFEM. Everyone interested in delving deeper into the topic are advised to consult the tool's official websites and contact the developers for more information. Simulation tools such as E-SeaFEM can be taken even further along the path of digitalization of naval design and calculation, giving rise to innovative solutions that allow the evolution of advanced digital twin models. So much so that Tdyn CFEM, the E-SeaFEM engine, has been used to develop and train a naval architecture web tool based on machine learning and artificial intelligence. This tool has been trained for single-hull displacement vessels, up to a certain fruit number, but work is continuing on its training to be able to include high fruit vessels. The tool, clearly disruptive in the naval sector, makes it possible to obtain results of ships' seakeeping behavior, RAOs, for example, of vital importance in the initial phases of the design process, with a simple click on a web page and in real time. Hope you enjoyed this presentation and that it was useful for you. Thanks a lot for your attention.